Hello everybody, my name is Veer Kumar and this is my task 1 submission for the Data Science and Business Analytics Internship at Cox Foundation. The problem title given here is predicting the percentage of a student based on the number of study hours. First, we'll import the necessary libraries such as pandas because we are working with data frames, numpy because we need to perform numerical operations here, matplotlib for visualization. We will read this data as a CSV file, print the head of this data. We are getting hours of study and scores. These are two numerical variables and they are more suited for linear regression. We will plot these points on a XY plot. X plot will have the hours studied and Y plot will have the percentage score. Clearly through this plot, we can find out that there's a linear relationship between the hours studied and the percentage score. So we most likely would tend to be using the linear regression algorithm machine. First, we will split our data into input and output variables. Input variables go into X and output variables go into Y. We will use iloc for this and dot values is the method. Further along, we're going to split into training and testing data. One point I'd like to mention here is that the test size here we have taken is zero point 0.2. 0.2 here means that 20% of the data of the data set is testing data, whereas the 80% of remaining data is the training data. Random state is equal to 0. This means random state equal to 0 means that our results for training and test data are reproducible. Hadn't I put this argument, each time we refreshed our code, we would get a new training and test data observations. So that's why to get reproducible code, to get reproducible results, and to get constant training and test data, we need to use random state, and we can initialize it to any given integer. Further along, we are going to use training methods to train our algorithm based on the train set. We're going to use linear regression method for this, and we are going to fit the x train and the y train variables for this purpose. We are going to now visualize the model. We all have studied y is equal to mx plus c. Here m is the slope and c is the y-intercept. These two coefficients help us in plotting a line through this earlier given data set that we had seen, that we had visualized. This line I have plotted is fitting perfectly into the data set. More so. Now let's see how our given line, which we have created here with the two coefficients, that is m and c, performs on the test set. And we see that it's performed fairly well on the test set as well. Further, we're going to make predictions now. We're going to use a function known as .predict, and we're going to pass in an argument known as xtest to that. This will make predictions for the output. We're going to create a dictionary, and through this dictionary, we're going to create a data frame. And we are going to create a data frame which will have actual scores as one of the columns and predicted scores as the other column. Here we can clearly see that there's a close match between the actual score and the predicted score through our linear regression model. Specifically for this task, we were given a challenge where we had to find out the score of a student who studies for 9.25 hours. For this purpose, I'm going to pass a variable named HRS, give it a value of 9.25 and pass it to the predict function. We, we realize that a student who studies for 9.25 hours will approximately get 93.69 marks. There are many evaluation metrics, and now we're going to do model evaluation. There are many evaluation metrics, and the one we are going to use here is going to be the mean absolute error. What is the mean absolute error? It is the difference between the true value and our measured value. Basically, the value we have got here is 4.18. The mean absolute error here is 4.18, which means that in each of our uh, predictions that we have made here, between the difference between the actual and predicted score on average has been 4 marks, roughly. That is what the mean absolute error here means. The true value minus the measured value upon the number of predictions.